Assessment of asset condition and performance. Good asset management practices in the water sector require that all phases of the infrastructure management system are maintained on a regular basis and in a proper manner, including repair, renovation, rehabilitation, and replacement. Assessment of the most optimal, the best way of infrastructure asset maintenance is the most difficult task for each PUC, especially having in mind the requirements for the cost reduction imposed by the founder on one side and customers' demands, along with the founder's demand to increase the service level and reduce tariffs. Therefore, the initial step in the assessment is the analysis of the life cycle of an asset. An asset's life cycle includes the production, construction, or installation phase, when maintenance or renovation are required, and the phase of its temporary or long-term withdrawal from use. Needs assessment of minor or major repairs, renovation, replacement is feasible if cost estimation for improvement and associated benefits are defined, and risk assessment is completed when the question "what would have happened if the maintenance had not been done" is answered. Only after the implementation of these activities and adequate information acquired is it possible to enact adequate decisions on infrastructure asset maintenance. Any PUC which implements good management practices will consider the following key business questions. 1. What type of maintenance, control, replacement, renovation of assets is needed and when? 2. How to determine what the best combination of costs, risks, and performance of asset is in relation to interventions undertaken. 3. Does it pay off to spend funds on performance improvement and risk reduction of the assets, and when we should stop doing that? It is not easy and simple to answer these questions. In order to answer the key business questions, it is necessary that the public utility company analyze the 1. Asset's age. 2. Desired performance for adequate service delivery. 3. Failure risk and consequences. 4. Intervention costs. Repair, replacement, renovation. Only after the condition, performance and risk assessment is completed, it will be possible to do the prioritization of infrastructure assets. Interventions on infrastructure assets should be done only when it is necessary. The public utility company must have a clear overview of the condition and functionality of assets in order to complete the assessment on the needs for minor or major repairs, renovation, and replacement. The condition of certain assets can be evaluated by visual assessment, site or desktop assessment, or by specific tests, but most of the infrastructure assets owned by the PUCs may be assessed only on the basis of knowledge and experience of the staff, as well as on the basis of failure history due to the old age. Basic assessment of an asset's condition should initially include physical condition and functionality, and other information can be added at a later stage. It is essential that such assessment is done individually for each category or type of the asset. The specific structures, reservoirs, distribution system elements, electrical and machine equipment ranked in hierarchical order will be elaborated in the lesson on infrastructure assets. This slide shows an example of groups of assets and methods for asset condition assessment used in the company Yorkshire Water Services Limited, UK. More information on the subject can be found in the Report on International Asset Management Practice. After the infrastructure asset condition assessment is done, further assessment is ranked on the basis of A. Previously defined criteria, B. Assessment aimed at defining maintenance and/or investment requirements. Criteria for infrastructure assets condition assessment may be based on a scoring system on a scale 1 to 5, where 1 is excellent, 2 good, 3 moderate, 4 poor, whereas 5 indicates failure. A more detailed assessment system may be used in addition to the physical condition assessment, such as assessment of operating performance, reliability, availability, and maintenance alternatives. The main reason for asset condition assessment is to determine the asset capacity to perform the required level of service, asset performance assessment. More information on infrastructure assets condition assessment may be found in the Municipal Asset Management Toolkit. This slide shows an example of criteria for asset condition assessment implemented by the company Yorkshire Water Services Limited, UK. A key to effective infrastructure asset management is its capacity to meet the required level of service. 3 criteria are applied in infrastructure asset assessment. 1. Performance assessment. 2. Risks assessment. 3. Cost assessment. The objective of condition and performance asset assessment is to create an opportunity for ensuring service delivery at a required level, to keep risk at an acceptable limit, and to reduce the total cost of the whole system. Systems and procedures for monitoring and measuring asset performance include: 1. Reactive monitoring means collecting comprehensive data about any failure, incident, or deterioration. 2. Proactive monitoring is an ongoing process which is compliant with the policy and strategy based on an asset management plan and includes effective procedures or other arrangements to control an asset throughout its life cycle. 3. Qualitative and quantitative performance measurements appropriate to the needs of the PUC. Indicators ensure a result-based approach to asset performance assessment. This complex system demands a certain level of competence and skills. The purpose of indicators is to identify and better plan the future interventions needs regarding a specific infrastructure asset. Monitoring and measuring of infrastructure asset performance is a complex process which should be regulated by a special written protocol or rule book. In order to introduce such a system, it is necessary to 1. Assess asset condition in reliable manner. 2. Provide all necessary data on assets. 3. Define asset condition and performance indicators. This is an example of infrastructure asset condition and performance assessment sheet. It includes the following: 1. Physical condition, including assessment of the actual assets condition as a consequence of aging, utilization, and maintenance. 2. Operating performance is an indicator of the asset's actual capacity to perform its immediate or future operating requirements. 3. Reliability assessment of an asset's capacity to perform its function under given circumstances for a definite period of time, also a failure frequency indicator. 4. Maintenance alternatives, including the likely interventions due to failure, which are regulated by clearly explained procedures.